Hello everyone. So this is our sixth video from our series Data Science with Python. So our today's topic is Naive Bayes theorem. Naive Bayes theorem is a classification model that is another classification model that we will study in this series. So Naive Bayes theorem are classification methods are based on Bayes theorem developed by the Reverend Thomas Bayes. Bayes' theorem update our knowledge about the data parameters by combining our previous knowledge with new information obtained from the observed data, resulting in updated parameter knowledge called the uh, Bayes theorem. That is, let me change the slide. So, definition: Bayes theorem methods are set of supervised learning algorithms based on applying Bayes theorem with the naive assumption of independence between every pair of features. So, this is the formula of Bayes theorem. We are supposing a problem of supposing a problem that we need to classify vectors x equals to x1 up to x tends to n into m classes c1 to cm. So we need to compute the probability of each possible class given x. So we can assign x the label of the class with the highest probability. We can calculate probability using the Bayes theorem. So probability of getting Ci from x equals to probability of getting x from Ci into probability of getting Ci upon probability of getting x. So this is the formula here. The prior probability of belonging to class I, PCI belongs to this, and P of x is the normalizing constant for probability of seeming the given input vector over all possible input vectors. Let's change the slide. And let's go to the data that we are considering today to apply this Naive-Bayes theorem in Python. Yes, so I took this data from basically Google, Braves AI. This is the data, and the problem statement is we want to classify whether a person will play golf or not based on the weather condition. We have the following data. So outlook represent the weather condition: sunny, overcast, and rainy. There are basically three weather conditions we are considering: temperature, hot, mild, and cold; humidity, high, normal, high and normal. Two types of two classified humidity, and windy is a condition, so it is true or false. Similarly with play ball. So here naive Bayes assumptions and calculating probabilities. So naive Bayes equation is probability to play golf divided by outlook, temperature, humidity, and windy. How these are affecting the probability of playing golf. So P outlook equals P outlook or P golf into P temperature upon P golf into P humidity. How humidity will affect of playing golf into P probability of windy depending on golf into probability of playing golf. So this is an example calculation. We'll calculate outlook. This is sunny. We are considering sunny. So when the outlook is sunny, what is the probability that the player will play golf is 3 by 9 into probability. Temperature equals to hot and player will play golf is 2 upon 9. Humidity is 3 by 9 and same for windy false 6 upon 9. We plug these values in naive Bayes equation and we'll multiply these all. So the answer will be 0.35. So we classify the new instance as playing golf in the probability of playing golf is greater than 0.5. Now we will go to the Python uh, IDE to apply this. Yes, so here is the data set that I showed earlier. Yes, and these are the important libraries that we will use below. So we will import these libraries and these functions. Then we will import the data. Then we will convert this data into data frame. Now we will encode this categorical data. So pt.getDummies. GetDummies is a function from Panda library. So this will outlook, temperature, humidity, windy. These are the column names, and these will get categorical through this the get underscore dummies function and get encoded into a this encoded underscore df variable. Now we will run this line. Then we will get x and y. X and y are the axis that we are working on. We are splitting the data into features and target. Now our features are play golf. Our target is play golf, and features are other than play golf that will target this. Now we are splitting the data. So test underscore split. And after this, we will model this categorical data. So we will model and fit it into X train and Y train. And Y is prediction. Y underscore prediction is a model that predict X test. And we will evaluate our model. So this is an optional code. We will calculate the accuracy about our model. 0.33, that is one third. Now we have test sample about overcast, rainy, sunny, mild, cold, hot, normal, high, and windy condition true. So these are the uh, data frames dictionary that we are using here. So let's collectively run these whole lines. This is an index to match the training data columns and fill missing values with zero. So we will run this line. Now, now we will run these code. This will generate the output. Zero point. This will generate the output 0.35. So this is it for. Thanks for watching.